Welcome to the video lesson on graphing a linear function. This is a review from last year, but good to go over some of the most important things. When you're graphing a linear function, there are two main methods that we'll be using, and you can pick whichever one is best for you. You'll never have to use one or the other. The first one is to make a table of values and then to graph those points, and the second one is to use the initial value and the rise over run, which is the slope, and we'll talk about that in a little bit. So for now, we'll talk about case one. There will be another video for case two. Case one is where the function is in function form. It's already isolated. Y is by itself on one side of the equation, and the other side is mx plus b, where m, the coefficient of x, is the slope, or the rate of change, and b, the constant that's by itself, not attached to the x, that is the initial value, the y-intercept. So method one was to use a table of values. And here are the steps involved. The first one is to set up your table of values. That's just making a grid that has an x and y. The second step is to pick some x values that work with your slope, and I'll talk a little bit about what that means. The third step is to plug in the x values that you selected and solve for the corresponding y values. And then the fourth is to plot the points, at least three. You really only need two to draw a straight line, but the third one ensures that you haven't made an error. If all three of them are collinear in the same line, then you're confident that that's the correct one. So here's an example, and I'll show you how this works. Step A, or one, is to set up a table of values. That's a real easy one. Just put a little x and a little y in there, and you leave space for three different sets of numbers. Pick some x values that work with your slope. There are two things to consider here. One is you should pick x values that will yield y values in the correct range. So here's what I mean by that. My initial value is -1. So when I'm graphing, I'm probably going to choose to scale my axes, the x and the y axis, by 1. So I'll go 1, 2, 3, 4, 5, etc. And the negative side, -1, -2, etc. So what I don't want to do probably is pick a number like 100 for x, because if I did, it would give me 3 times 100 minus 1 is 299. That would be too big for the scale of my graph. So probably I'll pick numbers close to 0. I'll pick smaller numbers so that it'll be easy to graph. And one number that I will almost always pick, regardless of the slope, is 0. I want to know what the initial value is, and I could just read it off. But the third step works whether it's the intercept or not. The third step was to plug in my x value and find the corresponding y value. And when I say plug it in, I mean into this equation. That's what this equation is. It means that whatever my x is, I'd replace it here. So in this case, my x is 0. I would replace it in here. And I would do 3 times, because remember 3x, when they're stuck together, means that they're multiplied. 3 times 0 minus 1. 3 times 0 is 0. And 0 minus 1 is -1. So -1 is the y value that corresponds with 0. This is one ordered pair. That's one point. The point 0, comma, -1. I'll do the same thing with others. I'll pick some other x's. I picked 1, and when I did, 3 times 1 is 3 minus 1 is 2. So 1, comma 2, that's a point. And I'll pick another one. I picked x is 2, and I solved, and I got 5. That's my third point. So my fourth step was to plot those points. So on my graph, let's say when I had 0, -1, that's the point where x is 0 and y is -1. I plot my point there. I'll do the same thing with 1 and 2. X is 1, y is 2. Now here I didn't write in my scale. If the scale isn't indicated on the graph, you can assume that it's going by ones, but most of the time you should include that. I'll try to do that in my next slideshow. And 2, 5, when x is 2 and y is 5, that's my next point over there. And now that I've got the 3, I connect them, the straight line. That's my line. That's all there is to it. There's one other consideration about picking the correct x values, and I'll show you what I mean in this example, because this is one where I have a fractional slope. Things work a little bit differently. So setting up my table of values is the same. Picking x's that work is very similar, and I'll always pick 0 first, and I'll write that in there again in a second. But there's a second consideration when you have a fractional slope as well, which is that not only do I want to pick x's that'll give me a y in the correct range or the correct interval, I also want them to be integers, whole numbers, easier to graph. So how do I get this to be an integer? Well, if I pick my x value to be a multiple of the denominator. The denominator here is 4. So if I pick numbers like 4, 8, 12, or -4, -8, -12, those are all numbers that will work out to give me whole numbers. And I'll show you that in my table. So regardless of that fact, I'll always pick 0, no matter what, with or without fractions. So when I plug in 0, I plug it into this rule now, 3 over 4 times 0. And then I add 2. Anything times 0 is 0, plus 2 is 2. That's my initial value. I could have just read that off the graph as well. Initial value is the value when x is 0. And for my next one now, I'm going to pick multiples of 4. So I'll start with 4. And it works out that when I plug in 4 here, either you can look at it as a 4 on top and the bottom, they cancel, or 3 times 4 is 12, divided by 4 is 3. Either way, when I add 2, I get 5. That's my corresponding y. And then I could pick 8. I could pick 12. In this case, I picked -4. It doesn't really matter if these are not in numerical order, because I only thought of picking -4 after I did my first two. And when I plug that in, then the 4 and the 4 cancel. I'm left with a negative. So it's -3. Plus 2 is -1. Or 3 times -4 is -12 divided by 4 is -3. Either way, when I add 2, I get -1. That's my third point. And I do the same thing. I plot these 3 points, 0, 2, 4 and 5, and -4 and -1. That's over there. And I connect them, and that's my line. Beauty. So real quick, the second way to do this using the initial value and rise over run. So I'll plot the initial value. I'll plot a second point using the run and the rise, and I'll show you what I mean by those, and then I connect. So a quick side note, in something like this, my slope, remember, is the coefficient of x. That's only true when the y is isolated, but that's what we're looking at now. That slope, 3 over 4, is made up of 2 parts. The number on top is the rise, and the number on the bottom, the denominator, is the run. The rise is what is happening up and down. It's rising. It's the vertical, and the run is side to side. It's the horizontal. In this case, my slope is 3. That's really the same as 3 over 1. And that means that my rise is 3 and my run is 1. The equal should have come in earlier on that animation, but I'll fix that later. So real quick, if I asked you to graph this using this method, here's how you would do that. You'd start by plotting your initial value. My initial value is 2. I put a point right in there. And then this rise over run business, my rise was 3, my run is 4. It means that from this point, from my initial value, I rise up 3, 1, 2, 3, and I run 4, 1, 2, 3, 4. How do I know if I'm running to the right or the left? Well, it's always, if it's a positive 4, positive numbers go to the right, positive rise goes up. If my slope was overall negative, what I would do is I would rise down and I'd run to the right. So overall, a positive slope should be going in this direction. It should move up to the right. A negative slope should move down to the right. In this case, I put my second point there and I connect them. I end up with the same answer as I did before because it's the same line and the same rule. That's it.